Fuels are any materials that store potential energy in forms that can be practicably released and used for work or as heat energy. The concept originally applied solely to those materials storing energy in the form of chemical energy that could be released through combustion, but the concept has since been also applied to other sources of heat energy such as nuclear energy. The heat energy released by many fuels is harnessed into mechanical energy via an engine. Other times the heat itself is valued for warmth, cooking, or industrial processes, as well as the illumination that comes with combustion. Fuels are also used in the cells of organisms in a process known as cellular respiration, where organic molecules are oxidized to release unusable energy. Hydrocarbons are by far the most common source of fuel used by humans, but other substances, including radioactive metals, are also utilized. Fuels are contrasted with other methods of storing potential energy, such as those that directly release electrical energy or mechanical energy. History: the first known use of fuel was the combustion of wood or sticks by Homo erectus near 2 million years ago. Throughout most of human history, fuels derived from plants or animal fat were the only ones humans used. Charcoal, a wood derivative, has been used since at least 6000 BCE for melting metals. It was only supplanted by coke, derived from coal, as European forests started to become depleted around the 18th century. Charcoal briquettes are now commonly used as a fuel for barbecue cooking. Coal was first used as a fuel around 1000 BCE in China. With the development of the steam engine in the United Kingdom in 1769, coal came into more common use as a power source. Coal was later used to drive ships and locomotives. By the 19th century, gas extracted from coal was being used for street lighting in London. In the 20th and 21st centuries, the primary use of coal is to generate electricity, providing 40% of the world's electrical power supply in 2005. Fossil fuels were rapidly adopted during the Industrial Revolution, because they were more concentrated and flexible than traditional energy sources, such as water power. They have become a pivotal part of our contemporary society, with most countries in the world burning fossil fuels in order to produce power. Currently the trend has been towards renewable fuels, such as biofuels like alcohols. Chemical fuels are substances that release energy by reacting with substances around them, most notably by the process of oxidation. Chemical fuels are divided in two ways. First, by their physical properties, as a solid, liquid or gas. Secondly, on the basis of their occurrence, primary and secondary. Thus, a general classification of chemical fuels is solid fuel. Solid fuel refers to various types of solid material that are used as fuel to produce energy and provide heating, usually released through combustion. Solid fuels include wood, charcoal, peat, coal, hexamine fuel tablets, and pellets made from wood, corn, wheat, rye and other grains. Solid fuel rocket technology also uses solid fuel. Solid fuels have been used by humanity for many years to create fire. Coal was the fuel source which enabled the Industrial Revolution, from firing furnaces, to running steam engines. Wood was also extensively used to run steam locomotives. Both peat and coal are still used in electricity generation today. The use of some solid fuels is restricted or prohibited in some urban areas, due to unsafe levels of toxic emissions. The use of other solid fuels such as wood is decreasing as heating technology and the availability of good quality fuel improves. In some areas, smokeless coal is often the only solid fuel used. In Ireland, peat briquettes are used as smokeless fuel. They are also used to start a coal fire. Liquid fuel. Liquid fuels are combustible or energy-generating molecules that can be harnessed to create mechanical energy, usually producing kinetic energy. They also must take the shape of their container. It is the fumes of liquid fuels that are flammable instead of the fluid. Most liquid fuels in widespread use are derived from fossil fuels. However, there are several types, such as hydrogen fuel, ethanol, and biodiesel, which are also categorized as a liquid fuel. Many liquid fuels play a primary role in transportation and the economy. Some common properties of liquid fuels are that they are easy to transport, and can be handled with relative ease. Also, they are relatively easy to use for all engineering applications, and home use. Liquid fuels are also used most popularly in internal combustion engines. Most liquid fuels used currently are produced from petroleum. The most notable of these is gasoline. Scientists generally accept that petroleum formed from the fossilized remains of dead plants and animals by exposure to heat and pressure in the Earth's crust. Conventional diesel is similar to gasoline in that it is a mixture of aliphatic hydrocarbons extracted from petroleum. Kerosene is used in kerosene lamps and as a fuel for cooking, heating, and small engines. Natural gas, composed chiefly of methane, can be compressed to a liquid and used as a substitute for other traditional liquid fuels. LP gas is a mixture of propane and butane, both of which are easily compressible gases under standard atmospheric conditions. It offers many of the advantages of compressed natural gas, but is denser than air, does not burn as cleanly, and is much more easily compressed. Commonly used for cooking and space heating, LP gas and compressed propane are seeing increased use in motorized vehicles. Propane is the third most commonly used motor fuel globally. Gaseous fuels. Fuel gas is any one of a number of fuels that under ordinary conditions are gaseous. Many fuel gases are composed of hydrocarbons, hydrogen, carbon monoxide, or mixtures thereof. Such gases are sources of potential heat energy or light energy that can be readily transmitted and distributed through pipes from the point of origin directly to the place of consumption. Fuel gas is contrasted with liquid fuels and from solid fuels, though some fuel gases are liquefied for storage or transport. While their gaseous nature can be advantageous, avoiding the difficulty of transporting solid fuel and the dangers of spillage inherent in liquid fuels, it can also be dangerous. It is possible for a fuel gas to be undetected and collect in certain areas, leading to the risk of a gas explosion. For this reason, odorizers are added to most fuel gases so that they may be detected by a distinct smell. The most common type of fuel gas in current use is natural gas. Biofuels. Biofuel can be broadly defined as solid, liquid, or gas fuel consisting of, or derived from biomass. Biomass can also be used directly for heating or power, known as biomass fuel. Biofuel can be produced from any carbon source that can be replenished rapidly, for example plants. Many different plants and plant-derived materials are used for biofuel manufacture. Perhaps the earliest fuel employed by humans is wood. Evidence shows controlled fire was used up to 1.5 million years ago at Swartkrans, South Africa. It is unknown which hominid species first used fire, as both Australopithecus and an early species of Homo were present at the sites. As a fuel, wood has remained in use up until the present day, although it has been superseded for many purposes by other sources. Wood has an energy density of 10 20 megajoules per kilogram. Recently biofuels have been developed for use in automotive transport, but there is widespread public debate about how carbon efficient these fuels are. Fossil fuels. Fossil fuels are hydrocarbons, primarily coal and petroleum, formed from the fossilized remains of ancient plants and animals by exposure to high heat and pressure in the absence of oxygen in the Earth's crust over hundreds of millions of years. Commonly, the term fossil fuel also includes hydrocarbon-containing natural resources that are not derived entirely from biological sources, such as tar sands. These latter sources are properly known as mineral fuels. Fossil fuels contain high percentages of carbon and include coal, petroleum, and natural gas. They range from volatile materials with low carbon, hydrogen ratios like methane, to liquid petroleum to non-volatile materials composed of almost pure carbon, like anthracite coal. Methane can be found in hydrocarbon fields, alone, associated with oil, or in the form of methane clathrates. Fossil fuels formed from the fossilized remains of dead plants by exposure to heat and pressure in the Earth's crust over millions of years. This biogenic theory was first introduced by German scholar Georg Agricola in 1556 and later by Mikhail Lomonosov in the 18th century. It was estimated by the Energy Information Administration that in 2007 primary sources of energy consisted of petroleum 36.0%, coal 27.4%, natural gas 23.0%, amounting to an 86.4% share for fossil fuels in primary energy consumption in the world. Non-fossil sources in 2006 included hydroelectric 6.3%, nuclear 8.5%, and others amounting to 0.9%. World energy consumption was growing about 2.3% per year. Fossil fuels are non-renewable resources because they take millions of years to form, and reserves are being depleted much faster than new ones are being made, so we must conserve these fuels and use it judiciously. The production and use of fossil fuels raise environmental concerns. A global movement toward the generation of renewable energy is therefore underway to help meet increased energy needs. The burning of fossil fuels produces around 21.3 billion tons of carbon dioxide per year, but it is estimated that natural processes can only absorb about half of that amount, so there is a net increase of 10.65 billion tons of atmospheric carbon dioxide per year. Carbon dioxide is one of the greenhouse gases that enhances radiative forcing and contributes to global warming, causing the average surface temperature of the Earth to rise in response, which the vast majority of climate scientists agree will cause major adverse effects. Fuels are a source of energy. Nuclear. Nuclear fuel is any material that is consumed to derive nuclear energy. Technically speaking, this definition includes all matter because any element under the right conditions will release nuclear energy. The only materials that are commonly referred to as nuclear fuels though are those that will produce energy without being placed under extreme duress. Nuclear fuel is a material that can be burned by nuclear fission or fusion to derive nuclear energy. Nuclear fuel can refer to the fuel itself, or to physical objects composed of a fuel material, mixed with structural, neutron moderating, or neutron reflecting materials. Most nuclear fuels contain heavy fissile elements that are capable of nuclear fission. When these fuels are struck by neutrons, they are in turn capable of emitting neutrons when they break apart. This makes possible a self-sustaining chain reaction that releases energy with a controlled rate in a nuclear reactor or with a very rapid uncontrolled rate in a nuclear weapon. The most common fissile nuclear fuels are uranium-235 and plutonium-239. The actions of mining, refining, purifying, using, and ultimately disposing of nuclear fuel together make up the nuclear fuel cycle. Not all types of nuclear fuels create power from nuclear fission. Plutonium-238 and some other elements are used to produce small amounts of nuclear power by radioactive decay in radioisotope thermoelectric generators and other types of atomic batteries. Also, light nuclides such as tritium can be used as fuel for nuclear fusion. Nuclear fuel has the highest energy density of all practical fuel sources. Fission. The most common type of nuclear fuel used by humans is heavy fissile elements that can be made to undergo nuclear fission chain reactions in a nuclear fission reactor. Nuclear fuel can refer to the material or to physical objects composed of the fuel material, perhaps mixed with structural, neutron moderating, or neutron reflecting materials. The most common fissile nuclear fuels are 235U and 239Pu, and the actions of mining, refining, purifying, using, and ultimately disposing of these elements together make up the nuclear fuel cycle, which is important for its relevance to nuclear power generation and nuclear weapons. Fusion. Fuels that produce energy by the process of nuclear fusion are currently not utilized by man but are the main source of fuel for stars. Fusion fuels tend to be light elements such as hydrogen which will combine easily. Energy is required to start fusion by raising temperature so high all materials would turn into plasma, and allow nuclei to collide and stick together with each other before repelling due to electric charge. This process is called fusion and it can give out energy. In stars that undergo nuclear fusion, fuel consists of atomic nuclei that can release energy by the absorption of a proton or neutron. In most stars the fuel is provided by hydrogen, which can combine together to form helium through the proton-proton chain reaction or by the CNO cycle. When the hydrogen fuel is exhausted, nuclear fusion can continue with progressively heavier elements, although the net energy released is lower because of the smaller difference in nuclear binding energy. Once iron 56 or nickel 56 nuclei are produced, no further energy can be obtained by nuclear fusion as these have the highest nuclear binding energies. The elements then use up energy instead of giving out when fused, and therefore fusion stops and the stars die. In attempts by humans, fusion is only carried out with hydrogen to form helium-4 as this reaction gives out the most net energy. Electric confinement, inertial confinement, heating by laser, and heating by strong electric currents are the popular methods used. World trade. World Bank reported that the USA was the top fuel importer in 2005, followed by the EU and Japan. See also. Footnotes. References: Ratcliffe, Brian A. Chemistry 1. Cambridge University Press. ISBN A0-521-78778-5. Further reading, Directive 1999 EC of the European Parliament and of the Council of December 13, 1999, relating to the availability of consumer information on fuel economy and CO2 emissions in respect of the marketing of new passenger cars, a PDF 140 KB. Council Directive 80 EC Fuel consumption of motor vehicles.